Hey everybody, it is Unit 12, Day 8, Monday, April 13th, 2020. Having deja vu because I already did this video when I thought we were going to have spring break. I hope you had a great fake spring break. So please take out your Unit 12 Kinetics and Equilibrium note packet to page 9. We are actually going to finish up the notes for kinetics. So this unit is broken up into kind of two sections, kinetics and equilibrium. So we're going to finish up kinetics today. It's pretty short. Before you watch this note video, please watch the TED Ed, What Triggers a Chemical Reaction. The link for that is on Schoology under the agenda for today. Make sure you have completed the potential energy diagram skill check from last week and the table I skill check from last Friday by tonight at 11:59 p.m. You want to make sure you're comfortable with that before you take the quiz. The quiz will be tomorrow on all the kinetics material, so all the note pages up to page 9. You don't have any other skill checks tonight. Just make sure you've done the 2 skill checks that were from last week by 11:59. The quiz tomorrow, multiple choice. You're going to get 2 attempts at the quiz. Take your time, make sure your notes are filled out. They're there for you as a resource, and make sure you have a reference table. All right. So today what we're going to talk about is entropy, which we've actually already discussed before, and then the difference between a spontaneous and non-spontaneous reaction. This should take maybe 5 minutes. So make sure with the extra time you have today, if you have any, that you review your notes, make sure you're comfortable with everything for tomorrow's quiz. All right, so I'm on page 9 of the note packet. I don't know why it says 13, it's page 9. Let me change this for you. 9, magic. Okay, and we're talking about entropy today. Entropy is something we have talked about in the past when we did matter and energy. And you don't need to know this, but entropy is represented sometimes by delta S. But entropy is the amount of disorder. So the amount of disorder or randomness of a system. So the amount of disorder or randomness of a system is called entropy. And there's a couple different ways you can look at the entropy of something. The first is that the entropy is going to increase as you change from a solid to a liquid to a gas. So if you look at these diagrams over here, we have a solid. A solid is very ordered. It's in a crystalline structure. It's very rigid. When it goes to a liquid, those particles spread out a little bit more. They can take the shape of the container. And then finally, a gas is the most random. So our entropy is increasing as we go from a solid to a liquid to a gas. So if you're ever asked which shows increasing entropy, you're going to have to look at the phase. And remember, if you see a parentheses S, that's a solid, parentheses L is a liquid, parentheses G is a gas. So that's one way you can look at the entropy and see if it's increasing or decreasing. The entropy of a system also increases when the number of moles of product, what you end up with, is greater than the total number of moles of the reactant. And I'm going to show you an example in a chemical equation. So if the moles of product are greater than the moles of the reactant, then the entropy goes up. If the opposite is true, it goes down. So let's take a look at this reaction right here. I have 2 moles of hydrogen gas plus 1 mole of oxygen gas. So remember, the coefficient tells you the number of moles. It's an invisible 1 there. So on this side of the reaction, I have 3 moles. All right, let's look at our product side. That produces or yields 2 moles of water. So I have 2 moles on the product side. So my number of moles actually went down as I go from reactants to products. So the number of moles decreases from reactants to products, which means that the entropy is decreasing, or the amount of disorder. So that's another way. I have less moles of product than reactant, so my entropy went down. And then the last thing is that the entropy of something will increase when a substance is broken into parts. So let's say, for instance, I had a cube and I crush it into a powder. That's increasing the entropy or the amount of disorder. The one you're going to see the most is going to be the one asking about the phases of matter. So knowing that as you go from a solid to a liquid, it becomes more disordered, and then going from a liquid to a gas even further. So that's really it for entropy. Just knowing it's the amount of disorder or randomness in the system. It's kind of just a vocab word. All right, and the last thing for kinetics is spontaneity, meaning a spontaneous versus a non-spontaneous reaction. We've seen the word spontaneous before in nuclear chemistry, but spontaneous means that something occurs naturally. So if something occurs naturally, we say that it is spontaneous. This means it favors, and favors the formation of products. So it occurs naturally and favors the formation of products. Spontaneous means on own. So it happens on its own. There is no external help. So no external help at all if it is spontaneous. A non-spontaneous reaction is one that doesn't occur on its own. It does not favor the formation of products. So it does not favor the formation of products. That's what we mean by spontaneous versus non-spontaneous. Now, there's two conditions that are going to favor a natural reaction that favors the formation of products. The first is a decrease in the heat of reaction, or delta H. Something is going to occur on its own if it doesn't require a lot of energy, right? So if we have a low heat of reaction. And a spontaneous reaction is also good when there is an increase in entropy. So you want a low delta H, but a high entropy. So summarizing that, nature has a tendency towards lower energy and higher randomness. So there will be a question on your test that will say something like, which conditions favor a spontaneous reaction? And what I want you to think of is a teenager. Nature is like a teenager. And this is going to be mean, and I shouldn't be saying anything right now because I'm still in sweatpants. But teenagers are lazy and they're disorganized. So just like nature, reactions are like teenagers. They are lazy, meaning a low heat of reaction, and they're disorganized, meaning a high entropy. So that's really it for kinetics. You need to know how to read potential energy diagrams. You need to understand how concentration, temperature, surface area, and catalysts affect reactions. You need to also know how to use table I. So please make sure those 2 skill checks from last week are completed by tonight, and make sure you look over your notes so you're ready for your quiz tomorrow. Adios.